Today we're going to talk about factoring, just like we did in the last section, except this time our ax squared plus bx plus c is the type that we're looking at. In the last lesson, the coefficient of the x squared term was a 1, so that would be the a value. In this lesson, we're going to deal with trinomials with a coefficient that is greater than the 1. So the first step, as we kind of have been mentioning through all of this, is to always factor any GCF that you see in the trinomial. That has to be done first, and then that'll make things a lot easier as we go. So looking at example 1. So factoring out the GCF. We've talked about how to do that. What you want to do is look for a common monomial, mixture of numbers and variables, that are in all of the terms, and it has to be in all of the terms. So if I look through 5x squared and a 15x and a 10, well, there aren't any variables that go through all three terms because the 10 does not have a variable. However, the number 5 is in common to all three terms. So if I remove the 5, so 5x squared divided by 5 is x squared, 15x divided by 5 is 3x, 10 divided by 5 is 2. Remember, when I factor things, I need to have the new factored look exactly the same as the original value. So if I use my distributive property, this could go right back to being the 5x squared plus 15x plus 10. So now, once we have the x squared plus 3x plus 2, as we learned in our last lesson, we'd be looking for factors of the 2. Okay, it's the c value. So factors of the number 2. Now, because it's a positive 2, that means that both of the factors are either both positive or both negative. But because the b value is a positive, it has to be that they are both the positive 1 and the positive 2. And again, we need to have the sum be the b value in the middle, which is the 3, and 1 plus 2 is 3, so that would confirm that that would be the factor pair that I want. Okay, so then we would keep the 5 out in front. Remember, we are factoring, so this still needs to equal 5x squared plus 15x plus 10. The two double bubbles would have the x's to start them, and then we would have the plus 1 in the first one, and the plus 2 in the second one, and then this would be factored completely, and that would be my answer after taking out the GCF and factoring x squared plus bx plus c. So then, when there's no GCF, this is the method that we're going to use. So when we see ax squared plus bx plus c, we use what we call splitting the middle. So here's how this works. For step 1, what we're going to do is we are going to multiply the a term, which is the coefficient of the x squared, and the c, the constant at the very end. And what we're going to do is make a list of the factor pairs of the AC product. So we're not just going to focus on the c in this case, so now we are focusing on the a times the c. So then what we're going to do is we're going to pick the pair that adds up to the middle term, so just like we did in the past. So we're going to pick the pair that works to add up for the sum of the b value in the middle. We are then going to split the middle term into these two terms. Next, what we do is factor the first two terms using the GCF. Then what we do is factor the second two terms using the GCF. So by splitting the middle term, the bx, into two terms, we will actually be creating 4 terms, which we'll show you in a minute. And what we're going to do is take the first 2, factor out a GCF, take the second 2 and factor out its GCF. If we've done this correctly, the terms in the parentheses should match. One of my binomials is the one with the terms outside the parentheses, and the other binomial is the one inside the parentheses. This will be what we would have as our factor answer from the trinomial we started with. So we want to make sure we put these in the double bubble method as our answer. So let's try a few examples. So in the first example, 4x squared plus 13x plus 3. Well, our very first thing to do is look for a GCF. There is no GCF for these three terms, so I would then move on to the steps that we just talked about. So the very first step is to multiply the A and the C value to create the factor pairs that we need to create the middle terms. So A times C, in this case the A would be the 4, the C would be the 3. That means we're looking for factor pairs that make 12. Now we also know that we are trying to create a sum of the B value, which is the number 13, which is a positive number. So again, our AC is positive, meaning the factor pairs are either both positive or both negative, but the sum has to be a positive number. So I can really just focus on my pairs that are both positive. And again, the positive pairs would be 1 and 12, 3 and 4, 2 and 6. And the sum, the very first one, is where I would get to that 13. That would be a 7 and that would be an 8. So there is the pair that I need to be using, the 1 and the 12. So now what we do is we move on to the next step. The next step is where we would then be saying we're going to rewrite this with splitting the middle term. So the 13x is going to be split. So if I do 4x squared plus x plus 12x plus 3. If you'll notice that my 13x, and I'll show you right here, my 13x right there has now been split into 1x and 12x. And so that's what it means by splitting the middle term. So from here, then we move to that next step that says, find the greatest common factor between the first two terms. So my first two terms are right here. Greatest common factor between 4x squared and x is simply x. If I remove the x from those first two, I would leave a 4x on the first term and a 1 on the second term. Okay, that is just taking the first one out for the greatest common factor of the first two terms. So the next, if I look at my second two terms, the greatest common factor between 12x and 3 is simply 3. And when I do the 12x divided by 3, I get 4x. 3 divided by 3, I get 1. Then when I move on to the next step, so the next step then said to us that we need to make sure that the binomial inside the parentheses is the same. Well, we do. We have 4x plus 1 and 4x plus 1. So to finalize this, we can take and make our double bubble. 4x plus 1 is one of our binomials, and the other binomial comes from these first two that are sitting right here, the x in front of the 4x plus 1 and the 3 in front of the 4x plus 1, and they actually become the other binomial. So they go together to become x plus 3. So this would be our final factored pair of the two binomials being multiplied together. Again, I won't go through every single one of these, but if you use your FOIL method, you should be able to get right back to where we started. If I was to do my 4x times x for the outside terms, I get 4x squared. If I then did x times the 1, I get x. If I did 3 times 4x, I get 12x, which added with the 1x gives me the 13x. And then 3 times the 1 is the 3 at the end, so it would definitely check. Let's move on to the next one. So again, very first question is there a greatest common factor? The answer is no. There is nothing that I can take out of these three terms. So then I'm looking for that AC value. So A is the 3, C would be the 2. When I multiply them, that means I'm looking for factor pairs of the number positive 6. The B value, which is where we're trying to get the sum, is going to be negative 7. So again, with the positive AC value being both signs are the same, I can either focus on both positive or both negative factors that have to add up to a negative number. So it obviously would only focus on my negative numbers. So if I do negative 1 times negative 6, that gives me the positive 6. That also gives me the negative 7. So right away I can see it. That's the one that I'm going to use to split the middle term, the negative 7x. So then I would write 3x squared minus x minus 6x plus 2. So again, notice how that is taking this negative 7x and turning it into negative 1x minus 6x, which is the same thing as negative 7x. So once I've split the middle, then I focus again the first two terms. What is the greatest common factor? Well, 3x squared and an x. Greatest common factor would be an x. 3x squared divided by x is 3x. Negative x divided by x is a negative or minus 1. Then when I focus on the next two terms here, looking at those terms, what is in common? Well, the number 2 is in common. And actually what I'm going to do is take out a negative 2. If I divide out a negative 2 from both of these terms, negative 6x divided by negative 2 gives me 3x. And the 2 divided by a negative 2 gives me a negative 1. Now notice what we said before was this binomial that's on the inside has got to be the exact same to make this work. So I needed to have the 3x minus 1 and the other 3x minus 1. So then when I use my double bubble, 3x minus 1 is one of the binomials. And then when I look at the other one, the x on the outside of the first 3x minus 1 and the negative 2 on the outside of the other 3x minus 1, those become x minus 2. And there is my final factored answer of that trinomial. Okay, moving on to the next one. So here we have another one that the AC is actually negative. So again, first step, is there a greatest common factor? The answer is no. Then I want to focus on the AC. AC is 2, which is the A in front of the x squared, times the C, which is a negative 7, which is a negative 14. My B value, which is the sum that we're looking for, is a negative 5. So here I got to think a little bit harder on what we're working on, but I'm thinking about my factor pairs of a negative 14, meaning one of my factors is positive and one of my factors is negative. So if I just start thinking about all my factor pairs, I would have negative 1 and 14. That would not add up to negative 5. I would have 1 and a negative 14. That would not add up to a negative 5. I would have a negative 2 and a positive 7. That would add up to a positive 5. But then when I do 2 and a negative 7, they would add up to the negative 5 that I need. So 2 and negative 7 is the factor pair that I need to make this work. So again, to split the middle, I'm going to do 2x squared plus 2x minus 7x minus 7. And again, just a reminder, this negative 5 right here, this negative 5x, is being split into a 2x and a negative 7x. So it's still the same, it's just not a negative 5x anymore. So once I have that next piece done, I focus on the first two terms. In this case, 2x squared and a 2x has a 2x greatest common factor with an x plus 1 on the inside. My second two terms only has a negative 7 in common, but when I divide out negative 7x divided by negative 7, I get x. Negative 7 divided by negative 7 is a positive 1. And again, there we can see those two x plus 1 binomials. Because of that, I can take and create my double bubble. I get x plus 1, and I get 2x minus 7 to create the other binomial. You should do a FOIL check to make sure it works, but that would be the answer and factor for that. So here we have another one, negative 4x squared minus 8x plus 5. So this time, when I do my AC that we are looking for our factor pairs is now a negative 20. So one of these factors will be positive, one will be negative. But we need the sum, the B value, to be a negative 8. So if I think this out a little bit here and be strategic, I need two factors of different signs to add up to a negative number, which means the negative has to be the larger of them. So again, you can start just trying to sift through all these factor pairs. But if I was to do a 1 with a negative 19, the negative 19 is obviously larger as a number. So 1 and a negative 19 is negative 18. So if I was to use the negative 1 and the positive 19, I would be on the positive side. So then if I just jump to the next one, so 2 goes with negative 10. 2 with a negative 10 is going to give me that negative 8 sum that we needed. So that's the pair that I want to split the middle. So then when I come back over here, I'm going to have negative 4x squared. I'm going to split that middle by having plus 2x minus 10x. That would give me that negative 8x down the middle, plus the 5. So here's where we look for the greatest common factors of the first two terms. Now in this case, I know we have a negative 4 and a positive 2. We also have x's that are in common. I'm going to take out negative 2x from both terms. Negative 4x squared divided by 2x is 2x. And 2x divided by a negative 2x is a negative 1. For the next term, I see a negative 10 and I see a 5. So I'm going to take out the negative 5. When I do that, negative 10x divided by 5 is 2x. I'm sorry, negative 10x divided by negative 5 is 2x, and 5 divided by negative 5 is negative 1. And again, we need to have those two binomials the same. So 2x minus 1 is the same in both. So that then becomes one of my binomials from the double bubble, and the other one becomes the negative 2x minus 5. And again, a FOIL check would verify that that does work to give us back to where we started. So negative 2x minus 5 times 2x minus 1 is the factored of negative 4x squared minus 8x plus 5. So next we have a real-life problem that we're working on. We have the length of a rectangular game reserve is 1 mile longer than twice the width. So just looking ahead and trying to sketch out some ideas, we have a rectangular, the reserve is a rectangular piece of land where these giraffes are from. We have a width and we have a length. Okay, length times width would give us the area, which this is referring to. We are given the area of the reserve is 55 square miles. What is the width? So we are looking for the final answer to be width, which is going to be our W. So first we want to look at how can we turn these two variables into one variable. Well, in that first sentence, it talks about how the length is 1 mile longer than twice the width. So 2w's plus 1 is also equal to the length. So we can now use that binomial to help us with figuring out now the area, but only having one variable. So again, area with length times width. We're replacing or substituting the length, or L, with 2w plus 1 times w. And we have an area that we already know, which is 55. Okay, so just like we saw in the last section, we can't just take that 55 and subtract it over until we kind of break up the grouping on the other side. So what we first have to do is use our distributive property. That's going to give us 2w squared plus w equals 55. But what we have to do is have one of these sides equal to 0. That's going to help us use that zero product rule. So I would use my inverse operations to move the 55 from the right-hand side over to the left-hand side, leaving us with 2w squared plus w minus 55 equals 0. Again, that 0 is key for us to be able to use our factoring. So here we are back with the ax squared plus bx plus c. We have a coefficient on the w squared that is greater than 1, so we're going to probably use this splitting the middle. So I'm looking for factors of ac that will give me negative 110. The sum of those also has to equal the b value, which is a 1 in this case. So really what I'm looking for are a couple things. Number one, the negative tells me I need one positive and one negative for my factors. Secondly, though, my sum has to be two factors that are really close to each other because they have to be added together to only produce a 1. So I really need to kind of think out what are the numbers that are going to work here. I think if we are good about this in our number sense, I can see right away that 10 times 11 would give me 110, and we need one of them to be negative. I need the larger number in this case to help us stay positive, so the negative 10 is going to get the negative sign, and that will give me that sum of a 1. So there is the factor pair that's going to help us. So when we come over here, we're going to split the middle, 2w squared plus, and I'm going to put that one there first, doesn't really matter, and then negative 10w minus 55. We've now split the middle, so now I'm going to look at the two different pairs. The first pair, the greatest common factor, will be w. When I take that out, I'm left over with 2w plus 11, and that will close off the first group. When I look at the second one, I can see a negative 5 in both of those. So I'm going to take out negative 5, and that's going to give me 2w plus 11, which works out. We need that to happen, which then means my final double bubble for the factoring part, the 2w plus 11 is over here, and we have w minus the 5 for the first binomial. So remember though, this all equals 0. So this is how we're going to be able to solve this. So from here, using our zero product rule, I can then do w minus 5 equals 0 would be one solution. 2w plus 11 equals 0 is another solution, or root. When I solve this one, I would be adding 5. The stylus is not cooperating with me. Adding 5 to both sides. So w would equal 5. When I come over here, I would subtract the 11 to get 2w equals negative 11. When I divide by 2, I'm really going to replace this stylus before the next video. We get w equals negative 11 halves. Now up above, the question asks us what was the width of the reserve. So obviously, when I look at the second answer for sure, can I have a width that is a negative number? No, we can't. That number is going to be thrown away. We will take the first one, so the width is 5, and I have to look back up here to remind myself, 5 square miles, so the width would be 5 miles. So we're going to have to give it a shot, see how it goes. There's definitely some more work that goes into this section than the previous ones. We will touch base as soon as we have a chance, and good luck with it all.